Hey everybody, welcome to Nautilus Live. We're so excited to have you here with us. My name is Megan Cook. I'm the Director of Education and Outreach for Ocean Exploration Trust. And we're stoked you come and joined us for our third in our From Shore to the Abyss project panels, which are chances for you to jump into conversation and meet Ocean Exploration Trust explorers, explorers from National Geographic Society, and our friends. We're live right now on the exploration vessel Nautilus off the coast of Mokuokeave, or the Big Island of Hawaii, Hawaii Island. And we're launching this exciting program called From Shore to the Abyss, where we're combining kind of the expertise you may know us from the deep ocean and bringing it to the shallow ocean to collaborate with others and help advance research and conservation of our global ocean and the stewardship of coral reefs. So wherever you are watching from today, if you are on YouTube, if you're on LinkedIn, if you're on Facebook, throughout the conversation, we want to know your thoughts. And if you just drop a comment into the question feed below, you will pop up into the conversation. And we're really excited to hear your thoughts. So, kick us off. Let us know where you are tuning in and watching us from today. Today's conversation is going to be about what inspires all of our teams. There are 5 different research teams here aboard from National Geographic Society over the next few weeks. And what brings all of us together is an inspiration of the ocean and an inspiration from animals. And that's what we're going to talk about today. I am super excited to introduce you to the host for today, who's going to lead this conversation, Daniel Kinzer. He is one of the education leads for the shark research team on board and the Malama Mano project. He is a technologist, an innovator, an educator, an ocean lover. He's based in Honolulu, Hawaii, but he's here with us right now. Daniel graduated from Vanderbilt University with a degree in psychology and in neuroscience. He has a Master's of Science degree from Arizona State University, studying the ocean and the desert, where he studied biomimicry. He has worked for the Punahou School and for the Mid-Pacific Institute in Honolulu, where he really brings together sustainability and entrepreneurship programs. He's a Grosvenor Teacher Fellow for National Geographic. This guy is serious, and he really supports community and nature-based innovation and regeneration programs. So we're so excited to have him here today and honored with all of his associations, the Purple Maya Foundation, Malama Mauna Lua, and now Nautilus. So aloha, Daniel.
Oh, mahalo nui, Megan. That's too much. It's too much. And it's such a pleasure to be here on Nautilus with you and this amazing crew. And aloha mai kako'o. Aloha, everyone. I'm very excited to be here with all of you today to dive into one of my favorite topics, biomimicry, from onboard EV Nautilus with this amazing panel. To me, biomimicry means learning from and then emulating nature's forms, processes, and ecosystems to develop more innovative and sustainable and regenerative designs, something our communities and our planet and our ocean desperately need. So when it comes to learning from nature, there's few better places to look than our oceans. Life was born out of our planet's ocean around 3.8 billion years ago. And our global ocean has been a continuously running research and development lab for inspiring innovations and adaptations ever since. So for the past 2 weeks on board EV Nautilus, we've been lucky enough to observe and learn from several species of sharks and marine mammals that call the ocean surrounding Hawaii their home. 2 times we've been greeted by a whale shark at the surface, approaching our boat, not us approaching it. We've encountered multiple sharks via the baited remote underwater video systems we've been deploying, or BRUVs. The marine mammals team has spent hours on and in the water with spinner dolphins using camera and acoustic technology that allows them to pinpoint exactly which animals are making which vocalizations. It's crazy to think that someday we might be able to communicate with these incredible relatives, ocean relatives of ours, the dolphins and the whales, thanks to this technology. So today we're going to hear from amazing people, both onshore and on the ship, who take inspiration from nature in their own work and can help us translate some of the genius found in this incredible ocean classroom. But before we hear from our first guest on today's Nautilus Live event, I'd love to hear from all of you, the audience. How are you inspired by nature? How does nature inspire you? What lessons have you learned from the natural world? Maybe even how it connects to your work. There's bonus points for ocean-related lessons and inspirations, and please type your responses into the chat box. How are you inspired by nature? I look forward to seeing. We have some people coming in from all over the world. This is really awesome. So fantastic. All right, I look forward to seeing these and coming back to what you throw into the chat. Um, Our first speaker, who we're really lucky to have with us today, is Dr. Molly Gabler-Smith. She's a functional morphologist who studies the anatomy and physiology of certain tissues and how it helps vertebrates function within their environment. In particular, she's interested in how the dermal denticles of sharks, the shark's version of scales, help sharks swim through the water more efficiently, right? She hopes to understand and share her research on the adaptations of marine vertebrates to the public and how we can harness these adaptations in the form of biomimicry. Molly, thank you so much for being here with us today, representing the hundreds of millions of years of research and development by sharks in our global ocean. And first off, how did you first become interested in the topic of biomimicry, and how do sharks inspire your work?
Hi, Daniel. Thank you so much for having me. Hi, everyone. It's great to see so many of you tuning in from literally all around the world. I'm actually joining from my home in Massachusetts right now, but most of my work happens in the basement of the Museum of Comparative Zoology at Harvard University. And so usually I'll go down to the basement if I have a specific species in mind that I would like to study. I will walk through our collections, which are shown here. I spin those knobs and get to a good species that I want to study. And I can take any species that I want out of the jar and look at any type of tissue, with it, whether it be muscle, skin, teeth, anything. So this is kind of a peek into the backstage of my everyday life. So the fields of biomimicry and bioinspiration are quite fascinating. Nature has really figured out many of the best designs for existing in a variety of different habitats. And so I'm particularly interested in the aquatic environment, as there are hundreds of thousands of marine species present, and more than 80% of the ocean has actually been unmapped. So what got me into the field was actually during my master's degree, while I was researching the muscles in the pectoral fins of stingrays. And so we were working with a bunch of engineers to build robots that mimicked a swimming manta ray. And it was really cool to see how biology and engineering could be combined to create something for humans to use based on nature. And this has actually been happening for quite some time now, with robots built to mimic things from manta rays, jellyfish, which is shown here, tuna bots, and many other animals. And so as many of you who may be tuning in right now, I have always had an interest in sharks. I spent a lot of my childhood visiting the Baltimore Aquarium because I'm from Pennsylvania, and I was always fascinated with looking at them swimming around. But I didn't even think about studying their skin until my PhD, when I was actually studying marine mammals. And at that time, we were tagging basking sharks in the Bay of Fundy, and their skin was really slimy. And so I did some research and found out that not only are they slimy, but their skin, as is with other sharks and rays, is covered in thousands of tiny structures called dermal denticles. And so this picture here shows you what they look like up real close, magnified. And so what's really fascinating about denticles is that they're made of dentin and enamel, just like our teeth. And so sharks are literally covered in thousands of tiny teeth. And I'm interested in how the surrounding environment, in this case water, interacts with the surface of the skin, and how we can potentially mimic shark skin for human purposes. And what's really interesting is that all species of sharks have denticles with varying degrees of shapes and sizes. For example, here are denticles from a chain cat shark, which is a benthic species that spends time on the ocean floor, and denticles on the bottom here from the great white shark, which is a fast swimming shark, as we all know, living in the open ocean. And just by looking at the different images, you can see that the chain cat shark denticles are larger, more triangular, and have more ridges, while the great white shark denticles are rounded with less ridges and are more overlapping. And you can imagine that water is going to interact with each of these surfaces in very different ways. And so to test how water interacts with shark skin, we actually use engineered or man-made materials. And this is because we can control different variables in these engineered materials, like size, spacing, angle, and so on, which we wouldn't be able to change in the biological or real tissue. So by using engineered riblets or denticles, which are based off of actual shark skin, we can print these materials and test them in a flow tank. And so far, scientists have found that denticles, or structures very similar to them, actually reduce the amount of drag and increase thrust on an object, which ends up making it easier for this object to move through the water. And so we can begin to manufacture surfaces and materials that mimic shark skin to enhance human life. And so I'm sure many of you know lots of these examples, but I'll provide you with a few here. And so the first example is shark skin from, it's very antimicrobial and also antibacterial. So Shark Technologies actually creates a film that you can apply to surfaces like railings and handles, and the material has ridges like shark skin, which inhibits bacterial growth. Lufthansa actually has applied riblet structures to some of their cargo planes to reduce drag forces, making them much more energy efficient. Shark skin material has also been used on some race cars to increase efficiency and speed. And I'm sure some of you have come up with other examples, which we may be able to discuss later. But I'll leave you with this last comment. Although there have been many industries that use materials that are similar to shark skin, nothing has come close to actually replicating it. Most man-made materials are not the same texture as shark skin. Either they're too flexible or they're too rigid. And many times we can't manufacture structures that are small enough to the size of denticles, which can actually be 1,000th of a millimeter. So sharks are really designed best.
Wow. Oh my gosh. Thank you, Molly. Sharks really are designed best, 100%. It's clear we're learning so much from sharks and that they're way ahead of us in terms of design in a lot of ways. It's cool to see you translating the sort of principles from shark skin into the laboratory and exploring that those phenomena in the stacks, and working in the lab. But as we catch up with the genius of their design, continue to learn from them, what does that mean for the kind of work we're doing in the field and for understanding things like shark ecology and conservation and our efforts to protect them and their ocean habitat? What are your thoughts on that?
Sure. So like I said before, there's still so much of the ocean that has been unexplored. And I think there's actually at least one new species of shark or ray being discovered every year, sometimes more. And that means that there's all of this untapped knowledge in the ocean. And so who knows what we might find in these newly discovered species that could help us make better material or better structures in the future. And so in that sense, the ocean habitat should actively be protected for future generations and for potentially future bio-inspired designs.
Oh, I love it. It sounds like you are spending a lot of time in the lab and in the stacks. I hope we can get you out on board the Nautilus one day. And I hope you're still getting to spend some time in the field observing sharks and their behavior. Is that the case? Do you still get out there from time to time?
Every once in a while. I definitely did a lot more field work during my PhD, but like I said, having the Harvard collections is really great because if you have a question, there's over 1 million species in that collection. And so you can essentially find anything that you could want to look at. But hopefully I can get on the Nautilus in the future.
Yeah, I know it'd be great to have you on board. And I love that. I love that you're able to really, we get these fleeting glances of sharks when we're out here doing research in the field, but the resources you have to be able to take that deep dive into the sharks' morphology and how they're really working is really incredible. And love that it translates into synthetic materials and things that you're making and testing and engineering. We'll come back to that, I think, a little bit later. So mahalo, Molly, for sharing that all of your fascinating work and the incredible adaptations and insights, lessons that sharks can offer us. And I'd love to know from the audience, like what other kinds of designs do you think sharks might inspire based on what Molly just shared with us or based on what you know about shark physiology and morphology? What else should we be looking at in sharks to help us design innovations? For more design innovation inspiration from sharks, I wanted to point to the audience out to asknature.org. It's created by the Biomimicry Institute. And if you search sharks, you're going to see a lot of cool examples of adaptations. So if you don't have any ideas yet coming to you for what design sharks might inspire, go check out asknature.org and see what you can come up with. It's a great tool to kick off the brainstorming for design. And of course, sharks aren't the only animals in the ocean that are inspiring new designs and innovations. Joining us from Pennsylvania is Dr. Frank Fish. His research is focused on the energetics and hydrodynamics of aquatic locomotion with biomimetic applications. In other words, Frank studies the ways in which animals swim and move through the water, and then uses that information to improve the performance and design of engineered systems like autonomous underwater vehicles, or AUVs, which of course the Nautilus is deploying in most of their missions. So today he's going to tell us about his work with whales to develop and design new products like windmills. Aloha, Frank. Please explain a bit about how you look at nature as inspiration for design, and welcome to the show.
Well, thank you for having me. Let me first just get past the burning question that is in everyone's mind. Yes, the name is real. It is Frank Fish. It's not made up. I didn't change it. I was born with this. So, let's get that right out of the way. The fascination with animals has really come into vogue recently because we don't know where the next great technological development is going to come from. And the oceans, the seas, are a potential source of ideas on how to actually produce biomimicry. There's just a vast number of organisms there that inhabit the world's oceans and provide an enormous resource in which we could replicate designs and functions that can improve or develop new technologies. Biological organisms are, in effect, living machines. They're under the same rules that we apply to physics, to planetary motion, and how your car works, and just the mechanics of everything. And so by looking at how animals have manipulated their particular mechanics, we can get an idea of how we can better improve some of the things that we have in our own world, our technologies. Animals are the result of natural selection. And because of that, they've developed various adaptations for their own survival. And this has taken place for millions and millions of years. And they've done the cost-benefit analysis, essentially. So we can see through what improvements they've made to their own body and the way that they function, that we can then integrate that into technologies to improve the way our own engineered systems work. Now, we do this through biomimicry. Okay? This is a field of study that attempts to incorporate the novel structures and functions of animals and plants and other organisms, and then put it into human-based technologies. And thus, we're trying to improve these technologies and look for also new ways that we hadn't even imagined previously to develop a whole new set of technological developments. For me, one of the animals that I've focused on and has really sort of become my spirit animal is the humpback whale. This organism is immense in size, and even with that, they are one of the most acrobatic whales that we can find out there. This little baby was swimming right up to me in the Cook Islands, and you'll notice that it can turn fairly well. It has these immense flippers. The species name of the humpback whale is Megaptera nova engeli, which means giant wing of New England. And you can see that giant wing. We look at a flipper, however, what we see is a structure that is 1/3 the length of the whale. And so for a 60-foot long whale, what we have then is a 20-foot flipper. This thing is really immense. But notice also on the flipper that there are these curious bumps, or what we call tubercles. Okay, for everyone who's ever flown in an airplane and seen a wing like structure, particularly if you're on the cheap seats that just look out over a wing and you can't see anything else, the wing is straight. But here we have these bumps, these tubercles. And so what this does is it changes the performance of that wing-like shape. If we look at the flow over a wing foil section, okay, with the tubercles, what we see is something rather interesting. Okay? Here we see that the flow over the wing goes on, and because of the way the flow hits, particularly between the tubercles, what we get are vortices, these spinning cyclonic fluid movements. And we see a pair of vortices then produced behind each of these troughs, each of these spaces between the tubercles. Now, what's happening here is the flow is actually moving away from the surface of that flipper or wing, and as a result, it's organized. Now, typically, if we had a wing and we had it canted at a high angle, what we call the angle of attack, okay, we reach a point in which the flow detaches and becomes very turbulent. And at that point, the wing starts to stall. It loses its lift. But in this case, because we have those vortices develop, what they help is that the flow going over the tubercles actually stays attached to the wing so that the wing does not stall, something you don't want to happen if you're flying in an airplane. And so because of that, we can increase the angle of attack on that wing or foil section, and it then produces a bit more lift. So the presence of these tubercles are quite important, and we can apply it then to various technologies. So we can put it on an airplane, for instance, okay, have tubercles there. What that essentially does is it keeps the wing from stalling. When you take off in an airplane, you're actually exceeding the angle of attack in which stall would occur on the wings. But we have all those slots and flaps, and as a result, that keeps the wing from stalling. But all that requires a lot of machinery. So if we could get rid of that machinery, we can make the plane lighter and more economical to fly. And also we can make it safer, less prone to stalling. There are other applications too. For one thing, we could take tubercles and we can put them onto not only the wings of airplanes, but ship rudders. And then probably important for the aspect of Hawaii, we could put it on the fins of surfboards and make them perform better. Or, as you just saw, we can put it on wind turbines and make them better able to produce electrical energy from moderate to low wind speeds. And so increase the efficiency of these wind turbines, also tidal turbines and fans. All of this from a humpback whale.
Wow. Oh my gosh, Frank, this is amazing. Thank you so much for sharing about the whales. It's I need all the help surfing I can get. So I love that potential application on surfboard fins. And it's amazing to me how, it's counterintuitive. Some of those designs inspired by these the humpback whale tubercles might be or feel at first, but they're really could lead to a dramatic improvement in fuel efficiency, like you said. And it's biomimicry is all about improving performance because nature is our best performers. They're so high tech in a way with all of their adaptations. So that's really beautiful. I'm really curious if we can send it over to Megan and see what kind of examples are coming in on the chat from our audience that's listening in.
Absolutely. Happy to jump in. And thanks everybody for dropping all those comments. Remember, you can just type them into the chat and we'll pull them in. Questions for the panel. Lots of sports references here, and I really like it. I think that's an area of our lives maybe a lot of people think about optimizing their performance out. So we've gotten some examples from, heat exchange of sharks where they can travel from warm to cold parts of the ocean and have adaptations for that. We've got dimples on a golf ball came in, thinking about ways to go fast and smooth through the water, whether that's swimsuits or maybe those smooth skin kind of designs somebody shared on the way in. So what I wouldn't give to be able to swim and travel like a whale, right? So really incredible performances. Thanks everybody. Drop your questions for the chat. We're really excited to have you in the conversation.
Oh, thank you so much, Megan, for keeping an eye on that chat, and to the audience for blowing it up with lots of great comments and questions and ideas. We love your creativity. Frank and Molly too. I have a question. Last week I had a student, a young Haumana in a class called Malamamano. He asked me if Nautilus, if the ship with all of its incredible technology and capabilities had any biomimetic designs on board. And I'm really curious if either of you were brought on board, or when both of you are brought on board, let's say, the Nautilus, if you were asked to identify places where nature might inspire some new designs and innovation, right, with all of the cool technology, the cranes, the drones, the navigation, the mapping, where do you think you might start on board the ship if we gave you that little design challenge and asked you to apply some of the lessons that you've discovered from sharks and whales? Any thoughts?
You can go first, Molly.
Okay, sure. I mean, the first thing that pops into my mind would be applying shark-like structures onto the hull of the boat. You could definitely increase the efficiency and potentially save on some gas, some money that might be able to be used for other research purposes, or maybe better food on the boat. I haven't eaten there, so I don't know. But yeah, definitely.
Food's really good.
Okay, well, okay. Then maybe we don't need money for food. But I definitely would think that applying shark-like things on the boat itself could actually be interesting and would help with efficiency.
Okay, so so in looking at the boat, there are a number of things. First of all, I'd love to come on. I'm going out to California to study sea lions this weekend, and I'm halfway there to Hawaii. But let's take a look. I would say to redo some of the designs. So the superstructure, that is everything above the deck, is sort of boxy, and we could streamline it just as dolphins and seals and whales are streamlined. That would be one thing. Another thing that comes from seals is that they have whiskers with little bumps on them, not quite the same as the humpback whale, but what these bumps do is as the wind goes past them or water goes past them, they get rid of any sort of vortices that start to produce. When you have ever heard telephone wires singing when there's a very high wind, that's due to the vortices coming off and making that sound. So we could have all those wires that you have on the boat actually have these, and that would quiet them down and make them more stable. Other things that you could do, you could put humpback whale tubercles on the propellers to make them quieter and prevent them from cavitating. That is actually making little bubbles that from the propeller motion. So these are some of the various ideas that you could have for putting it onto the Nautilus.
It looks like we have an expedition proposal here. I think maybe we're the beginnings of putting something together. But mahalo Molly, mahalo Frank. It's such a gift to have the incredible capabilities of sharks and humpback whales who are, making their long journey from the colder, nutrient-rich water of Alaska, British Columbia to Hawaii right now. We'll have thousands of whales, I think, down here in a matter of just a few weeks, and see those transformed into insights for our human design and innovation. We'll talk a little bit more later about what that means to really, to honor these animals that are contributing their incredible sort of evolutionary success for our own benefit, what that means to us. But first, I'm really honored to introduce our next guest and good friend, Dr. Keolu Fox. We were lucky to spend the first week of our current expedition with Keolu on board, learning so much from him. He calls Moku Okeawe home. His life and DNA are deeply rooted in this Aina and this land and this island and the ocean that surrounds it. So he had to head back home to San Diego, where he's currently a professor at the University of California, but he's joining us virtually. Most of his work focuses on questions about the human genome, the genetic materials that make us who we are and play a role in our health. He is also Native Hawaiian, Kanaka Maoli, who uses his genetic research to help understand Indigenous history, rectify injustices, and pave new ways forward in medicine. It's important to recognize that Indigenous cultures around the world, including the Hawaiians, have been drawing inspiration in their human-made a world from nature for a very long time. And so this is a practice that the ancestors knew very well. So here's a rich understanding of the stories, cultural practices, biological systems, engineering of the Hawaiian people who have thrived as an integral part of island and ocean ecology in the Pacific for 1,000 years. And Keolu, after hearing from Molly and Frank, thank you again for being here. After hearing from Molly and Frank, what you do might seem like a little bit of a departure from the concept of biomimicry, but how would you draw those connections? How would you argue that nature and the biological systems within it inspire you personally, as well as your work? Over to you, Keolu.
Aloha kako, everybody. Dan, that was such a kind introduction. I don't think I've ever seen somebody just nail every single one of these. It's remarkable, and it's a true honor to be here. And I'm also a huge fan of biomimicry in all types of different ways. As you said, coming from Hawaii, we have some really unique ways of thinking about this. Just in terms of scale, I think we've really talked about taking attributes from certain features that natural selection has really provided for many of these creatures over time. But I draw a lot of inspiration from the way we've cultivated our aina and land, and the way we've built in all of these systems of what I think scholars call industrial symbiosis. But this is the idea that you would create circular economic systems, technologies that we've iteratively improved over time that are thousands of years old, that maybe to the casual onlooker appear to be invisible. So when John Muir rolls up, in the Sierras or different places, he assumes that these places are pristine, when in reality they've been cultivated for thousands of years by indigenous people. And that seamlessness, invisibility, is something that I think we should really be striving to achieve in design. It goes beyond camouflage. It goes beyond many of these things. It is a complete harmony that we achieve. And what we do here at the Indigenous Futures Institute at the University of California, San Diego, is we try to take indigenous knowledge systems, like some of the things I'm going to talk about, and modern sort of Western cutting edge technologies, and you can imagine them as distinct elements, and bring them together to create new alloys. So many of the things that we're working on in that space are applicable to things from, architecture to the human genome. One could argue that something like mRNA vaccines are biomimicry. We're literally tricking the immune system into producing products and components that you need to fight off different viruses, right? And that's a really important piece. But in Hawaii, we have something called the Ahupua'a system, and it's a really special land management and division system. It is not just found in Hawaii. I think there are other kinds of ways to think about this. Oh yeah, here we have a beautiful picture of this. And what our ancestors did is they just utilized gravity and the fact that we have a lot of elevation and high islands. And so you would have systems where you have phytonutrients that are basically through gravity and moving from one subsistence type of agriculture to another. Maybe it's at for Mauna Kea, for example, producing fresh water that's going into an orchard or a uala farm for sweet potato, and then those phytonutrients will go down into the lo'i where we cultivate taro, and then those will move into the next part of the system. So it's like which is a fish pond you can see here at the bottom. And this system is dialectically intertwined by nature, and it is optimized to create sustainability and abundance. That's the lifestyle. That's what we do. That's original OG sustainability, is all about abundance. And one of the most fascinating things about these systems are that they don't just, it's not a static thing. Like each season, you can change the boundaries of these systems. They breathe, they're dynamic. They're not just in place. And that's one of the problems with the Cartesian grid, is that when you break down land into these unnatural squares on a grid, that is not biomimicry. You're forcing the natural divisions of land into a specific understanding of mathematics, and that doesn't really suit planet Earth. It's not correct mathematically, and it's not optimized for sustainability or abundance. So I think those directions in terms of thinking about the invisibility of design are going to be really important as we move forward with many different things. The other thing that I'll mention just briefly before we kind of move into questions is I think there's going to be a lot of really interesting biodesign and biomimicry as we move into the future of computation itself. So the way we design algorithms, there's a structure to that. There's scripting, there's a rhythm to that. We have to think about the actual lines of code that we're using. What are the languages we're using? Did everyone here know that the language R is designed by, created by an indigenous person, a Maori man, Rasi Haka? That's why it's R. It has a different rhythm to it. It has a, right? So as we move forward to design hardware and software, how do they emulate the connectivity that we find in the human brain? How do they emulate the connectivity of really useful and efficient networks of sharing information and data, like fungal networks, for example? So we will move forward in those directions inevitably. And I think it's going to be a really beautiful, efficient world. Mm-hmm.
Oh, mahalo nui Keolu. I love this vision of like indigenous design practice, biomimicry, being an invitation of being like reconnecting to these natural networks, to the way that the planet actually operates, rather than sort of forcing our own shallow understandings onto our beautiful planet, our beautiful ocean. And it starts with, Molly starts with this shark teeth denticles, right? These small skin scales, and it goes all the way out to really caring for the whole planet. So I love that it invites us to think at that whole scale, right? Where we're designing products, but we're also designing systems and processes. And so I think I really appreciate all three of you for all of those insights and sort of taking us on that journey through time and space to try to think about how biomimicry really serves as this awesome invitation and inspiration for just reconnecting us with the natural world and redesigning ourselves back into that fabric of life in the ocean, on the planet. That's amazing. That's amazing. We do have a lot of questions coming in from the audience, so I'm excited to get to those. And maybe I'll throw this first one out to all of you. And all three of you can sort of take a turn. Your careers are quite different. Your paths seem quite different. It's great to have the diversity here. But people are curious, kind of, what can we do to sort of, or what sort of steps could we take to get into these fields, right? What's a pathway to? Obviously, we're talking with three doctors. You guys have done a lot of education, but I know that other life experiences have also influenced your journeys. So, what would you say to people? Say, I want to get involved in the fields that you all are working in, and in biomimicry in general. Who wants to go first?
I'll take a shot. I would say just ask a question. Okay, don't necessarily come at it from the standpoint of, I really like this animal, what can I do with it? It's look at around, see what we need to improve or what needs to be invented, and then ask the question, is there an organism that can help me in that regard? And by doing that, you can have better progress, I think, in making a biomimetic technological innovation.
I guess I can go next. I'm laughing because I actually did my master's with Frank Fish, so my trajectory is very similar to his. But I mean, yeah, so I did my undergrad, I did a master's and a PhD, but I would second what Frank said. definitely look around you. There's always something that you can ask a question about in nature, as we've seen through this bio-inspiration and biomimicry panel. Don't be so narrow-minded. Open your eyes to nature around you, and I'm sure you'll find a very interesting question to ask. And also don't expect that you have to be in an engineering field or some type of physics background, because I came from a biology background and I serve as a biologist on many panels or projects where engineers are involved, but they need to understand how the actual animal or system in biology is working before they can design something based off of it. So don't think you have to do engineering or physics, which is very interesting and very good knowledge to know, but also you can be any type of science major, but have any science background and also work in this field.
Mahalo, mahalo, Molly.
Oh yeah, I'll just add to that. I think those are tremendous insights. It seems like I read this biography recently about Leonardo da Vinci, and he was like a real, I mean, you want to talk about pioneers of biomimicry, like look no further than that. But what you notice from that man and his genius is that he's a slow thinker. He takes time to make observations in a world where everything's coming at you at 120 characters or little mini video clips on all of these social media things. I think people need to take time to think slowly and make and practice the mindfulness of observation. This is like undefeated in terms of producing good science, good art, and true deep understandings of things. Like you said, Daniel, like moving beyond like this shallow understanding of stuff. And that is a skill that you have to cultivate, and it requires patience. So that I would advocate for. And then beyond the physical world, I just challenge like all the youth. You guys are digital natives. This stuff comes so easily to you. The next generation, please try to apply these ideas in different places and spaces. And that really will extend to the digital world. And I don't mean the metaverse. I mean optimizing and reducing how much carbon and heat we produce when we create data. These are things that we are going to have to do. And that will involve a fair amount of understanding of biomimicry.
Oh yeah, mahalo keolu. I love it. And I love the book recommendation. Yeah, that's a biography of Leonardo.
Walter Isaacson wrote it. Yeah, it's good.
Yeah, he's a great author. So check that out. I wonder, Molly and Frank and Keolu too, any other, if people are interested in learning about these fields, what can they go and watch? What can they go and read? What sort of things are you guys taking in as to help sort of shape your own thinking in what you're doing?
It's become more difficult in that there's been just an explosion, proliferation of the number of articles that are coming out. For most people, however, you can start off by just reading various books and even watching television, and probably there are websites too that they focus on biomimicry and bio-inspired design, and then get into it. And you can take the physics and mathematics and chemistry and biology and even earth science and then start to apply things. But just expose yourself to as much as possible. I came up with an idea on how baby ducklings, why they follow their mother in single file to get an energetic boost. And that was from walking across a bridge every day when I was in graduate school over a river and seeing the ducklings. But I had read books on hydrodynamics. And so it made perfect sense to me that there was a hydrodynamic reason for doing it.
I love that. Little baby ducklings. So cute, but also source of so many interesting insights, I'm sure. That's great. Molly, how about you?
Well, I can't say that I have been reading much other than scientific articles lately, but I was just at the Georgia Aquarium in Atlanta, And because that's really the only chance I get to see whale sharks, I'm not on a Nautilus and I don't get to go diving. But just standing in front of their big tank, watching all the sharks and the rays and other fish swimming around, I feel like you could come up with so many different questions about biomimicry or just how these organisms exist too. So just, again, standing out in nature, going to an aquarium, if you can't actually go diving with these animals, can actually create many really cool, interesting questions and might lead to a really cool discovery.
Oh, I love that so much. And it relates back to what Keolu was sharing about how can we just spend more time in deep observation. And if we're going to sort of remember ourselves to the natural world and those networks, then we have to spend time in them intentionally. And so wherever you can find that, right? And wherever that's available to you in your environment, might be in the stacks of the museum where you have access to all kinds of cool examples, or it might be your local aquarium, or I'm sure there's a lot of people out there. You can throw your own recommendations. What are your favorite kind of nature inspired or biomimetic shows or episodes or podcasts or books that you've read? We'd love to get your recommendations in the chat. We had a cool question coming in from, let's see, I think Sharon Goolsby is asking what I think is a really, really great question. And Keolu, I'd love for you to kind of start. How can we apply these concepts of biomimicry at all scales to some of the issues that we're facing globally or nationally across the United States? These might be social or environmental issues, but we have places where we're facing droughts, wildfires, sometimes even things like political instability. But how can we apply biomimicry to those scales, or what sort of opportunities come to mind first when you think about applying biomimicry to these sort of larger challenges that we're facing as a society?
Yeah, that is a profoundly important question. So I'll try to unpack parts of it and just say that the way many different places, I was in LA recently, and I think that's one of the most poorly designed cities in the world. I think it's extremely wasteful. I think it just bugs me every time I fly into the airport.
We still love you, audience members. If you're from LA, we still love you. But
yeah, we love you. We love the Lakers. All good. But I'm just saying there's this dialectically intertwined nature that you find in other places. So as we move forward and plan new cities, maybe you should put the bakery next to the brewery, because you can take excess yeast from one to the other. This is the same principal idea that you find with an ahupua'a system. This is industrial ecology and industrial symbiosis. So if we want to be more efficient and want to make the most of the resources that we share, we need to find, search for, and design and prioritize symbiotic relationships. And that it really comes down to the way we manage many things. So as people transition from harmful petroleum-based vehicles to electronic vehicles, how is that going to work? Are we going to have more efficient energy grids in anticipation of rising temperatures? We're already seeing this happen with a lot of EV charging stations. If you know that, you should plan for that. But you could take that idea in terms of manufacturing and other things to another level. And that's just, it requires a high level of coordination. And that can be daunting sometimes. But I think that we will inevitably have to arrive there out of necessity and desperation if things continue on their current course.
Oh, I love that. I love that. Specifically, Keolu, I'm curious, and Molly and Frank, this also connects to what you were sharing. So feel free to jump in. Molly, you were talking about the antimicrobial dimensions of shark skin, and Keolu, you work a lot in public health and especially supporting Indigenous communities and understanding how their sort of health data can maintain sovereignty over that. But we're curious how biomimicry could be used to. We have an audience question. How could biomimicry be used to improve public health?
Yeah, I mean, I could take a stab at that just recently thinking about all of the kind of hocus pocus in the microbiome world. There are real legitimate entry points for thinking about this that will and can advance public health efforts specifically in a kind of preventative way. But I don't, and I would love to see that. But if you're trying to rewild your gut microbiome, and that comes from intellectual property that was derived from an indigenous community, maybe the Hadza, then then you commoditize that, they deserve a cut of that, or all of the cut of that. And so we have to find more equitable ways to think about sharing the benefits of innovation. So when we talk about DEI, it should be diversifying my equity and investments for communities who have been historically taken advantage of. As we mimic things and we understand where that innovation comes from, that the provenance of that and the intellectual property that's connected to that data is extremely important. And it could advance a lot of indigenous people's goals, for example, buying land back, and many, many other things that lead to cultural revitalization. So I'll just leave it at that.
Oh, I love that. Molly or Frank, you want to jump in?
Well, one of the big problems we have, not just in the sort of proximal analysis of health, but more ultimately, is we're facing rapid climate change and an overabundance of CO2. And organisms have a way of dealing with this. I mean, we can plant trees, yes, but that's only, to my mind, sort of kicking the can down the road. What you want to do is you want to store the CO2 where it's basically not available later on from decay. And that is animals like corals and other organisms have been able to take carbon dioxide and with calcium and put it into stone, where it's pretty permanent. What we know of as limestone is actually the fossil remains from these organisms. It's been storing carbon dioxide for years, and we could get around that. If we could also figure out energy from the standpoint of being able to replicate photosynthesis without the plant itself, again, we can remove carbon dioxide, and we can maybe provide a new way to generate energy the same way we do with solar cells. And then, of course, as I mentioned, the humpback whale has the ability to show us where we can go with windmills and fans and make them more energy effective. So all of those things really play into, ultimately, our health and survival.
Yeah, planetary health, right? That's the goal, and it's going to be inspired by nature and inspired by our kopuna, our ancestors, our indigenous way of being. And I think that's, centering that is really important in this conversation. Molly, did you have some thoughts you could share as well?
Yeah, just a quick end thoughts, I guess. So yes, we definitely use biomimicry in the public health world. Like I said, the sharklet technologies have been designing these biofilms that they can put onto highly touched surfaces. And I think really the point of that is that it's able to, bacteria and microbes are unable to actually stick to the top of these surfaces. And so that kind of prevents lots of bacterial growth. And it could be really used instead of using harsh chemicals on surfaces to clean. This might apply better than using chemicals or synthetic materials. And I see someone in the audience brought up synthetic horseshoe crab blood. That's also a great example too, because we know that the medical field is harnessing synthetic horseshoe crab blood because they have these specific proteins that are able, I think it's anti-clotting factors that they have that we can use in the medical field. I also know of some research being done in cancer biology People are looking at how certain algae might be able to serve as vectors as getting medicine into cancer patients. So there's a lot of examples happening right now for public health.
Oh, I love it. And at so many scales again, right? We're looking at, things from like what we're putting on our hospital surfaces all the way and public spaces all the way out to designing kind of circular regenerative economies that are that value the original IP, right? Coming from nature and from indigenous communities. And I want to kind of close. We have about just a couple minutes left, and I'd love to close with a question about that. I love that Keolu brought up IP. Nature for a long time and a lot of for the last couple hundred years has been something that we see as a resource to consume and extract from. Indigenous communities have been seen in that way for even longer. And so how do we, what can we do? What do we do in your practice to really honor these incredible animal adaptations, honor the indigenous cultural practices and knowledge that goes into creating these innovations? What is our responsibility to nature and to indigenous communities? We don't have the best structures, right? Like legal structures and economic frameworks, financial frameworks for honoring that. So, what are some first steps that we can take? Keolu, you touched on this a little bit, but Molly and Frank, you as well. Like, how do you honor these animals that your career is really sort of now built on, these incredible adaptations and capabilities that they're offering us and the indigenous communities who have stewarded these places? Curious on your thoughts.
Yeah, sorry, I get excited on this one. So we're thinking very deeply about this. I mean, given the success of many of these mRNA-based vaccines and the future trajectories for genomic medicine and precision-based medicine, and knowing that all of the beautiful diversity that we observe in human populations, we are a reflection of our diaspora, right? We are a reflection of our migratory history. So you have incredible populations of people all over the world that represent where they're from. That's, I mean, I think for the most part, what indigeneity is. Whether it's high elevation adaptation in the Himalayas or all of the island hopping that's occurred throughout Oceania. Now, what that also leads to is incredible insights into biological mechanisms. And that can be reverse engineered into biomarkers that can be commodified. And that is known. There are many different companies that are moving in that direction to develop treatments that are based 100% on biomimicry at that scale. And knowing that, the vast majority of communities that have participated in this space have not received any benefits, we started Variant Bio. And that is a Seattle-based entity where we give proceeds from the treatments that we create back to the communities who participate in something called benefit sharing programs. So we're providing 4% of equity to our participants. And we're providing free access to the therapies that we create to individual participants and community members. That to me is disruptive to the whole industry. And it speaks to data equity, intellectual property, and is disruptive in new ways. And I hope that we can see more of that in the conservation space. But for now, check it out.
Thanks, Keolu. Real quick before I send it back to Megan to close us out, Molly, Frank, what do you guys do to love the animals you get to work with and learn from?
Oh, I just get to play with them. And that's the fun thing, is to be able to get close to them. I mean, to get in the water with a humpback whale and, be close to it, to work with sea lions and all sorts of different animals. It's just absolutely fantastic.
Awesome.
I know we're running out of time, but yeah, I would second that. Definitely get outside and see them. And if you can't see them in your backyard, definitely go see them in a zoo or aquarium.
You all are amazing. We appreciate the audience, this panel. You've been so fantastic. I've learned so much. I'm going to throw it over to Megan because we are all out of time to help close us up, and appreciate you too, Megan, for being here. And aloha, everyone. Ahui ho.
Thanks everybody for this Awesome panel and sharing your passions. I was inspired thinking about the bulbous bow of Nautilus. It creates a vortices and a pressure wave as the ship moves through the ocean. But one of the things about observing nature and seeing, building my own joy and then seeing joy in nature, which I think is a great way for all of our audience to connect, is sometimes, just sometimes, we'll get to see marine mammals like dolphins playing in those vortices too. So that design is, feeding back and maybe helping them have a great time and contributing something back to those animals who we drew that inspiration from. If you have more questions, drop them in the chat. We're always happy to connect with you on all of our platforms and channels. Thank you for the questions that did come in from our audience all over the world. Our next event, we're going to hop on live next Thursday, and we have a really exciting conversation about the current state and the future design and inspiration of where expeditions go from here. How are they structured? Who's involved? And we have some wonderful cultural knowledge holders, researchers from Nautilus and from National Geographic Society and Harvard University are all going to come together and join that conversation. So we hope you'll tune in and meet us there. Until then, be with us, explore with us during this From Shore to the Event, From Shore to the Abyss expeditions. You can follow along on Facebook, Twitter, Instagram, TikTok, LinkedIn, YouTube, and nautiluslive.org, where we can't wait to have you with us and continuing to experience the joy and the wonder and the inspiration that the ocean brings us. So see y'all